Welcome back, students. So we're going to start into our next section, which is talking about how we can represent a function and how we can use other representations of functions to create more representations of functions. So we'll get into that. Quick reminder, a function is a relation that for every x value there is exactly one y value. The fun way I described it was that our x's are not two-timing or cheating on our y's. So for each x value there's exactly one y value. And we talked about how to determine if a relation was a function from pretty much every single one of these ways that we can represent a function. But let's just go ahead and get started on how we represent a function. So we can represent a function in four ways. We can do ordered pairs. We could do, we do a table. You don't need me to write it. So we can do ordered pairs, we can do a table, we can show it in a graph, or we can show it with an equation. All of these are representing the exact same function. So if you notice here, I have 128, 256, 384, 128, 256, 384. This one added a whole nother point. And then here we have 128, 256, 384, and 112. And then here's the equation of that form of y equals mx. Our y-intercept is 0, so we don't have to write the plus 0, but we're basically, for our y value, is just taking our x value times 28, right? Because we're going up 28 each time. So all four of these are representing the same function. So let's get into some examples. During 1 hour of walking, you burn about 257 calories. The total number of calories burned is a function of the number of hours you walked. How can you represent this situation in four different ways? So I think in this case, writing an equation will be the easiest thing to start with. We know that we are going to burn 257 calories in 1 hour, right? So calories is our y, and hours is our x. Okay, so this is our y and this is our x. And our change in y always happens over our change in x, right? So my slope is going to be 257 over 1, which equals 257. Now, why do I show you this here? Because what if it gives you 260 calories in 2 hours? Then we would do 260 over 2, and that would tell us how many calories in 1 hour. So that's why I'm showing you how I'm setting it up, and then when I reduce it, this is what we end up with, right? Because 257 divided by 1 gives us 257. So that's my m. We're going to plug that into y equals mx. Why am I not putting a plus b? Well, because if I've exercised, or if I haven't walked a single hour, then, meaning I've worked 0 hours, then I'm not going to burn any calories because of walking. And so we know that it's starting at 0, 0. And so my equation is going to be y equals 257x. So that's representation number 1. Representation number 2 would be a table of points based off of that equation, right? X, Y. We already said that if we exercise 0 minutes, we're going to have 0 calories burned. And we know if we exercise 1 minute, 0 or 1 hour, I wish I could talk today, that we would have burned 257 calories. So then I'm going to do another one. So if I do 2, I'm going to plug 2 in for x. I'm going to take 257 times 2 for 2 hours, and that means I have burned 514 calories. And for 3 hours, I'm going to take 257 times 3, and I'm going to get 771. And then I'm going to go ahead and do 4. So 4 times 257 is 1,000 1,028 calories. And so there's my table. So that's 1. This makes 2. From my table, I can make a list of ordered pairs. So I'm going to have 0, 0. Put my little bracket. 1, 257. 2, 514. Oops. And 3, 771. And I'm going to close it off there. We could put in the 4, but I ran out of space. So here I am representing it as a list of ordered pairs, or we could have done it vertically. And last, I'm going to do it on my table. So I'm going to label this hours, and this calories. And I'm going to make this go by ones. 1, 2, 3, 4, 5. And then I'm going to make this go, just to make this easier, by 257. So this would be, because I already have these numbers, 514, 771, 1,028. Sorry, this 514 does not look like a 514, and here I am just erasing a whole bunch of stuff. That's the kind of day that I'm having. So here's 514, and now I'm going to graph it. So 0, 0, 1, 257, 2, 514, 3, 771, and 4, 1,028. And this one would have a line. I know we didn't go over the lesson that talked about which ones would have lines and which ones wouldn't. But basically it comes down to this. We can figure out to the minute how many calories burned. So we are including the calories between our points. So we have the equation. That's 1. The table. That's 2. The list of ordered pairs makes 3, and our graph makes 4. So that is how we can represent the situation in 4 different ways. All right, last example, we're going to talk about which table could be a view of the function represented by the graph. So this is just taking and matching this table to the graph, which, guys, you already did in our interactive slideshow. So this should be, we've already practiced this. In your Math Excel, it's actually going to leave you blanks in your table, and you just need to come to the graph and fill in the blanks. So here, all 3 of them have 0, 0, which is good. And then I'm going to check. So if I go to 1, so I'm going to check our 1s here, right? Oh, and this one doesn't have a 1. But if I look at where my x is 1, then right here, that point is 1, -3. And so right here, I know it cannot be this one, because at 1, negative, my blue line is at 1, -3, not 1, 3. And so now I know it's this one. So I'm going to check the next one. I'm going to go 2, and I'm going to come down here. And this point is that this is -4, this is -5, that's -6. So this is 2, -6. Now, just to make sure that this one doesn't work, so right now this point, and this point are on my graph. On this one, this point was, but that point wasn't. And right now I know 0, 0 is. So this is saying -1, 1. So if I go to -1 and I go up, well, here's 1, and that's not where my graph is. My graph is at -1, 3, right? -1, 3 is where my blue graph is. And so it's not going to be this one. Now, if it had down here, actually would have been up there, but if it had, say, -1 and blank, asking you to fill in this blank like on Math Excel, you would fill it in with a 3, because when we go to -1 and we go to the blue line, it's at 3. Or if it gave you 6 and it's asking you what is the x value, then you're going to go where y is 6, you're going to go to the blue line, and then you're going to go down and, oh, well, that's at -2, and you'll fill in the box. So that's what it's asking for when it asks you to complete the table based off of the graph. If it's asking you to complete the table based off of an equation, then you're just going to take the x values and plug them in and find your y values. But if it's asking you, here's the graph, fill in the rest of the table, you're just pulling the points right off the graph. Use what they give you. All right, I hope that helps. Until next time,